This video is made possible by the collective efforts of these aspiring science students. Good day folks, in this video we are going to comprehensively uncover one of the devices used in science, the ammeter, underlying which is the definition of ammeter, the ammeter circuit, working principles and types of ammeter, the applications of ammeter, and how to use the ammeter. We know that current is the rate of flow of charge. It is a stream of charged particles such as electrons moving through an electrical conductor or space. But how do we measure the current? Or what device do we use to precisely measure the current in the given circuit? In doing so, we use ammeter. Ammeter is a device that is used to measure the amount of electric current that runs through a circuit. The standard unit used to measure electrical current is called an ampere or ohm, hence the name ammeter or amperemeter. The ideal ammeter has zero internal resistance, but practically, the ammeter has small internal resistance. The measuring range of the ammeter depends on the value of resistance. The symbolic representation of the ammeter is a capital alphabet A that looks like this in a circuit. To fully understand the mechanism of the ammeter, we have to look in its backbone. Using the ammeter diagram, we can see its components comprising of the battery, the load, and the ammeter in the circuit. An ammeter must be connected in series circuit to measure the current through a device, because in series circuit, the same current flows through all the devices. So, the current flowing through a device will also have to pass through the ammeter and the reading will be measured. The principle of ammeter is that the resistance and inductive reactance must be very low. Ammeter has a very low impedance as the voltage drop across the ammeter should be low. For an ideal ammeter, the impedance must be zero so that the voltage drop across the instrument is zero. The ammeter cannot be connected in parallel because of the aforementioned reason. Also, connecting an ammeter in parallel may result in short circuit and the current passing through the ammeter might burn the instrument. If that is the case, then the ammeter must be in series circuit. There are two types of ammeter: the analog ammeter and the digital ammeter. Analog ammeter makes use of a similar to that found in a compass needle, wherein the needle points to a particular amount of current that passes the ammeter. On the other hand, digital ammeter displays the measured current on a liquid crystal display. The application of this device will range from the schools to industries. These are used to measure the current flow in the buildings to ensure that the flow is not too low or too high. This is also used in manufacturing and instrumentation companies to check the functionality of the devices. It is used with a thermocouple to check the temperature. Moreover, electricians frequently use these devices to check the faults of the circuits in the building. So, how do we use ammeter? The first thing we need to do is to secure safety precautions when using ammeter. These include wearing clean and proper gloves, checking the battery, checking the electrical circuit, and checking if other materials are intact and viable. This is the ammeter illustration. The ammeter being used is a digital ammeter. The circuit is composed of parts such as the battery, the lamp, the black and red leads, and the digital ammeter itself. The first thing you need to do is setting the ammeter current type and range. If your ammeter divides the range of current into settings, choose the highest setting. Choosing the highest setting on your ammeter from the outset will prevent you from blowing the meter's internal fuse if the amperage is too high. Battery-powered circuits run on DC. Other power supplies may be AC or DC, and some can alternate between both. The next thing you need to do is testing the internal fuse of your ammeter. Your ammeter should have two leads, an input the positive and an output the negative. Hold this together with your ammeter on. If your resistance is low, your fuse is good. The resistance reading of your ammeter will be indicated on a display on the front of the meter. You may have to adjust the power range before it can read the low level of a working fuse. Most ammeter fuses can be easily replaced or reset. though this process will vary according to your brand and model. If you adjusted the power range lower to check the fuse, reset the range to its maximum to prevent the fuse from blowing when taking the actual amperage. The next thing is breaking the circuit, but before you do, make sure the power is off and all batteries are removed to prevent getting zapped. The ammeter will be tied into the circuit at this break, so that electricity passes through the meter on its way to the item being powered, allowing the meter to take a reading. You may be able to break your circuit by loosening the fasteners connecting wiring to the power source's negative terminal or at the power input for the item B receiving power. If you can create a break in the circuit at a negative terminal or power input, you can cut, strip, and then re-splice the wire. Part 2. Typing in an in-series ammeter to take a reading. Connecting the ammeter leads to the circuit. The negative end of your ammeter will connect to the power source side of the broken circuit. The positive end will connect to the opposite side, so that the ammeter bridges the break. Red will represent positive and black negative. The most common used ammeters have clamps that allow them to easily attach the wires. Other models may use metal probes that will wrap the wire around. Then the next thing is restoring the power to the circuit and taking the reading. Switch the power source back on or reinsert the batteries for the circuit. Electricity will now pass through the meter, causing it to display the amperage of the current. Depending on the strength of the circuit you're testing, you may need to reduce the range for the power gauge until the display registers activity. Bare wires shouldn't touch anything while the circuit is powered. Doing so could cause the circuit to short, an electrical fire, or a false reading. Then the last thing we need to do is to cut the power and return the circuit to normal. Now that you have your reading, you can turn off power to the circuit once again. Remove the ammeter and refasten the circuit's wiring or splice back together wire that's been cut. That will be all, folks. Thank you very much.